You can go into solution time step, which is not part of the standard actually. And then they have a higher interface, which I introduced later, Modflow API, which you also integrate. And that's what I wrote. So I made it nice so you can actually explore Modflow interactively in a notebook and do step-by-step going through a simulation and inspect all the Fortran variables. And not only read them, also modify them. So you have interactive Python experience, and you don't need to know that Fortran is in the background to the most part. Good. So that's what you can do with it. So that's the thing. So it's funded by the Deutsche Bundesstiftung Umwelt, so a German foundation for environmental science, and it's a collaboration with TUBAF, the Technical University Bergakademie Freiberg. There we had this research project. Lucy is here, she was involved in there. So that's how it's developed, and you can access Modflow at runtime. You see, and this is, you can have a listing. You say, okay, give me all the packages, and Modflow is organized in packages. All these packages are active now, you can see it. And then it's essentially how you can write a pretty simple comparison, pretty simple loop. And this is a model loop, and you can interface with Modflow at runtime, and you can do something. You can extract variables and can say, oh, good, this is a well head, so pumping well, the water level in the well. If the water level in the well has fulfilled some condition, I do something and I can change something. And here actually I modified the pumping rate of the well. So that's something usually you do with the input file. You write the input file, let the model run, look at the output. Here I can change these values right in the middle of the simulation, which makes a lot of things possible, which would be much, much, much harder otherwise. Good. So that's this part for the Modflow side. The FreePy part, it's what actually I was sprinting on it yesterday. I want to improve it a little bit. So it's around, I think there's 2013 version. There's the first paper I published on it with David Parkhurst was 2011, so it's even older. But the first public release was on PyPI. And this one now added this FreeCRM support, and I can also inspect. So this is all at runtime. You can look at all these things in Python, Jupyter Notebooks. You can look at all these variables. These are the constituents in FreeC. And then so this FreeCRM provides a nice interface to couple things. They have a YAML input file. It doesn't specify anything. And here now you can interactively look at the FreeC part. So everything that makes a much better development experience, because you can interactively look inside what's happening, and you don't have to rely on any kind of print statements and outputs and something like this. It can be very, very interactive. Good. So that's what we have here. And then how does it work? So this ground water, there's multiple parts. You have the flow. So when you flow, you solve a partial differential equation. Modflow solves it with a finite volume approach. Yeah? This finite volume approach allows very flexible grids. You can have rectangular grids, you can triangle grids, you can Voronoi elements, which is kind of polygon-like elements. And then you have the transport. And here we need only one transport only one component. We have to transport many. So to do so, and to get it in parallel, Modflow only knows one component, so I need to actually create multiple Modflow models, one for each component. And that's what I'm doing here in this pre-processing step. So I have these input files, and I essentially create n Modflow inputs. So like I have 8 components or 10, I create 8 or 10 input files. This can be pretty easy. You have like a mother model, which has most of the information, and then you have these 8 submodels that only have the information that's different, the concentration of this components, and that's usually not too much. Most of this is in the mother model, and you see you have for each component you do have one, and there's something special. You have the charge component, and you also carry around the oxygen and the hydrogen, all kinds of this chemical stuff. And that's why I do have this model, and then you can end up with all these models. Yeah. So since I can reference most of the models, reference most of the files from the mother models, or they need to copy around physically files, they just say, okay, my input is there, and only the one that I override is where I have it. So that's what I did. And then you can make it natively parallel, yeah. And they can use multiprocessing, because now I can load. Actually, I have to do, because I need to. When I load Modflow, I can only load one Modflow in the process. So each process loads a Modflow, and you end up with this with a Modflow. And you see, you have, I don't know how many components you have, and so many processes you can start. Of course, it doesn't make sense I have to start more process, then it might have processors, then you don't get a full performance. But if you want to get full performance, you need a machine with enough processors to accommodate this one. But then you can really saturate your cores there very nicely. And then you do geochemical processing. Then this one I hand over to EuroSciPy. And because it's different here, everyone transports the chemicals for the whole model. Here's different. For each cell, you have to do chemical reactions. So each cell needs all the components. So you have to kind of rearrange. So you have n parallel components moving around, then they stop, and then they react. And that means for each cell in the model, I need to react with other guys, and I need all of them around. Yeah. To do so, I use this EuroSciPy. And the EuroSciPy, fortunately, this EuroCRM supports OpenMP threads, so I can run it in parallel also. So I can run the things in parallel, and I can specify how many threads I want. I say, okay, I have 8 cores available. I want to have 8 threads. And then this EuroCRM, which is written in C++, takes care of doing this in parallel. It also supports MPI. I haven't used it yet. So if MPI is for distributed computing, so if you want to go even bigger, you can go in the cluster, and then you can run this computation on multiple machines. For this, you would need to set up MPI. I haven't done this yet, but it's in the documentation of EuroCRM to do so. MPI typically is not the easiest thing to work with, but it should be possible if you really want it. So I haven't tested this one, but theoretically, it should work. Good. So that's how it works. So here we process parallel. This is the process parallel stuff. Here we are thread parallel, and these are C++ threads, so they're really parallel. Like the other session, which is much bigger. Talks about multi-threading in Python, which is not there yet. Actually, I tried multi-threading and tried my example much slower with multi-threading than the other ones, somehow, with Python 3.14. So, okay, so that's what you can do, and everything runs in parallel, and then you can oversaturate the thing. All the computations are done in either Fortran or C++, and Python is moving the data around, though the Python is not the computation heavy part, but it's steering the whole thing. It's working the whole thing. Good. So the main thing is now we have yet another model. My main objective was to minimize the new things. So I want to reuse the inputs and the outputs of the existing models as much as possible. So that's so what I need one of these. This is the main configuration file. This is a YAML file that essentially just says, okay, this is this part, and I can specify. You see the EuroCRM, you can specify how many threads you want, and then you specify some of this input data. And these are native input data to EuroCRM. So I didn't invent any new input for EuroCRM, and I didn't invent any new input for Modflow. Essentially, these are just references to Modflow files, and I can specify things like this. You need a boundary condition, and which boundary condition is delivering something. Like you have at the boundary of your model, you have some source of constituents that flows into model, and you specify this one. That's pretty much what's new. You have to specify these things. The rest stays the same. You see, we have this the setup, and these are native files for EuroCRM, which I can show in a minute, and these are native. These are the time configuration files I need to show you also, but the other ones aren't. These are native files of Modflow. Yeah. So this little thing is what I had to change to make it work, and I use this TOML file for the configuration, and then I need a few things in the input file, and I try to also make it as little invasive as possible. So these are essentially native input files of Modflow, and these are native input files of EuroC. So this is a EuroC thing. Nothing is new. I have different solutions, and this is native EuroC. Yeah, give it a different name, but it's still a native EuroC file. So we have two solutions, like one starting solution for the whole thing and one for the boundary condition. And this is an exchange. So the water travels through the subsurface. The constituents can exchange with like clay. It's a cation exchange, and clay has a lot of cations. So if cations travel along, they might be picked up by the cation and disappear from the solution. And this one you can model with this thing here. So, and then this is Modflow, and Modflow allows a few additional. These are native Modflow input files that don't change much. Yeah, and then you can this solution number will be put in here, and you can associate where the solution is. So you have a distribution in your file, and then you just say, okay, this solution is there and this is there. That's something you have to do, but still there's no new input format. You can use all the tools you have for your Modflow, which is important, and no new tooling necessary. Here you can also, this one allows you to use an auxiliary keyword, so Modflow has this built in, so I can put something additional in the Modflow input that has some special meaning somehow, and I can give it auxiliary thing, and then you can specify the concentration which we put there. And here, this would be the solution number that would be associated with it. So the main thing is there's nothing new. You see, this is a constant, has the 1, and the solution 0 is the basic one, is a 0. So you might not recognize the formats, but believe me, these are native ones, and people use this model know these formats, and there's nothing new. Everything can be consumed by the existing models. Good. So, and now let's look at some results of what's coming out of it. And there are some very basic examples. This is a very, very basic example. It's a 1D exchanger thing, so it's like a column experiment, and you have your solution, chloride, potassium, nitrate solution, you have your exchanger, and this one can exchange. And you have chloride and calcium coming in as a source, and it travels through. So if you wouldn't have this exchanger, you would have a breakthrough curve, and everything would break through at the same time. But since you have an exchanger, those components travel in a different speed, and that's what you can see here. So if the exchanger wouldn't be there, there would be one breakthrough curve. Now you have a multitude of breakthrough curves, and they're all somehow different. Yeah, they're all somehow different. That's the chemistry behind. And now I compare my solution with the PhD 3D solution. So this is my solution, this is PhD 3, and see, it's pretty much the same. There are some small differences which are mainly due to dispersion. There's something called dispersion. So when something travels through the groundwater, a few things travel faster, some go slower. And all those models have something called numerical dispersion, because the numerics kind of introduces dispersion anyway, so you don't have to do much. And this is slightly different, as you can see here, but not much. So this pretty much the same thing. Something is a little bit shifted. You can fiddle around with the parameters maybe, but I can pretty much reproduce this one, what Frixie is doing. So this is a standard single thing. You can also run the same thing with Frixie itself. And then here we have to turn down the dispersion quite a bit because it's like a piston flow. Good, but you can also do more sophisticated ones. And fortunately, I find Yannick Skowiak from the University of Oldenburg, and he's an expert in reactive transport modeling. He's been involved in PhD for many, many years, and he worked with my model, and then he used some much more sophisticated one. You see, this is an like a 2D setup, and you have this many different areas in the subsurface. You have a flow in this direction, and you have different zones of things, and you have NEPL, which is this a non-aqueous phase liquid thing, so that's like a kind of carbohydrate, black petroleum or something like this. So it's those other things that have different densities and different flowing around. And you see, you have this toluene, which is one of them, and you have many of these different constituents. And you see that's going off, and have the pH value, we have a calcium, and so on. And again, we compare our solution. So I don't go into chemistry into deep here, but we compare our solution with the PhD 3D, and these lines are pretty much on top of each other. There's very small differences. So even this way more complex example to show a non-heterogeneous subsurface and quite a bit. And you see also you have pyrite and geodite, which are minerals and calcite. So there's not only things dissolved in water, but things also precipitating, and they show the same behavior. So it's a very nice corresponding between the models. So it seems like it does something pretty useful. And then finally, another one, uranium, a different type of example. So because this Frixie is very, very flexible, it can do all kinds of geochemical reactions, and this would be like radioactive stuff in there. And you have some uranium that's released someplace and moves through, and you have some decay, and the same thing here. Yeah, I can again reproduce the results from PhD 3D, which is the standard, obviously, we compare it to, and we can produce pretty much the same thing. So this is the publications where it comes from, and this is the setup when you have these different zones here. You have an oxidized zone and a reduced zone. When you have some mine water coming, if it's uranium, that's the setup, and then you can see it. But I'm really concerned that the lines are on top of each other. That tells me yes, they correspond. So it looks like it's doing something correct. Good. So this is still a pretty young project. So it works, and Yannick could pick this up pretty quickly. I was amazed that he did so, but he has a lot of experience anyway. But in terms of, I didn't introduce too much new, obviously, which made it very easy for him to pick it up. So we will add some more benchmarks to see how it goes. So we have some good ones. The documentation it's there, but it's pretty basic. So there's some room for improvement. We'll be working on density-driven flow. If you have saltwater intrusion, saltwater is heavier than other groundwater, and there are some different forces if you have density-driven flow. We can also couple in heat transport, energy transport, which is important. So different temperatures might have influences on the chemistry. So ModFlow supports this already. So internally, ModFlow also couples different models. This would be another coupling. So just the same thing as you coupled flow and transport. Internally in ModFlow, you can also couple in temperature, and then you would set the plant temperature. And of course, I have another thing. It's called Pit Lake Q, which is my Pit Lake model, which is also for post-mining, so water quality in lakes. And they are very heavily influenced by groundwater. And now I would be able to couple potentially the groundwater to a lake. Yeah. So and then maybe you get some feedback from somebody else who's using it about usability, how this works, what we can improve there, and also maybe add a more official API so people can even program on it even more. We haven't done this yet, and of course we want to improve further. Good. So documentation is up. You can pip install or conda. I think you have the conda install right now, and then because there are some upstream problems with Freak CRM to be the right version, but otherwise it's pretty easy to install. So if you feel like you can try it out, otherwise I welcome questions.
First of all, thanks for the talk. That was really interesting. The first question that I have is because I don't know anything about groundwater modeling. Is the simulation software 2-dimensional or 3-dimensional, and is there also an influence of depth and an increase in pressure?
Yeah, so it's sort of 3-dimensional. So you can do both. You have 2-dimensional. These two layers they are coupled. So if you have groundwater aquifers, there are 2 dimensions, and you have exchange between those. You can represent 3-dimensional systems. You can also even have some of these discretizations allows you totally 3-dimensional discretization. Typically people do layers, and all the layers have the same cell layout, but you can have different ones. I had never seen anything alive like this, but it's possible. And you can have influence steps. So one of them would be this density-driven one. So you can simulate that one, but you would need to put some input. Typically for the groundwater, the concentration difference are not so big that it makes important. Difference would be like the Netherlands. They have the salt water from the sea coming in, which is much heavier. That can also be a model.
Okay, thanks. And the second question is, how large is the error that you get through the calculation loop that you showed us, that you calculate the distribution for every element at a point, you do that in parallel, then you perform the reactions, and then you repeat that infinitely until you converge on something. Did you manage to find out how large the error is from that, compared to having reactions happen while the...
Yeah, so this one you have to try out, but you can always change the time step. So this would be, there are some conditions, some numbers that tell you, because you don't want, in one time step, the rule of thumb, in one time step, you don't want things flying through multiple cells. One time step, you want to only progress a part of a cell. Or there are some numerical criteria that give you this one, and you have to make your time step smaller. And engineering, you just try it out. You make a time step 10 and see if it changes, and then you make a time step bigger, see if it changes, and then you get some empirical feeling what's going on. This is very different depending, like if you have cut and exchange, things are much slower. So the cut and exchange slows things down. You might go with a bigger time step because essentially the flow itself is the same, but the transport is delayed. Then you might go with a bigger time step.
And just to follow up on that, is there any statistical uncertainty on it, or is it fully deterministic, just from my understanding?
It's deterministic. So it's physical based. We solve partial differential equations, and there's no statistical, there's no stochastics in there. So you still go to do multiple scenarios because the thing you don't know are the parameters. The big unknowns are parameters of the subsurface. You don't know, the hydraulic conductivity is a very big unknown. It can be easy in order of magnitude up or down. And usually what you do, you calibrate before. So this assumes you have a calibrated flow model that you say, okay, I have observed values and I can reproduce observed values with my model. And for this one, I calibrate them by my parameter. Parameters is a big thing. That's always the, yeah.
Thank you. Very interesting talk. You said it's basically modeling PDEs.
Yeah.
Is that Navier-Stokes equations? Or?
Yeah, so in Canada it's Navier-Stokes, but the Navier-Stokes can be simplified a lot. You start with big Navier-Stokes, and the velocity is so slow you can throw out the velocity term, and you can throw out all these impulses because there's everything. So in the lake is very different. If you do in the lake, because the lake is many orders of magnitude faster. So we talk about 1 meter per day flow. In the lake, you talk about meters per second. Though it's orders are different. So it's so slow you can make the equation itself is much easier. The problem are the parameter. So in the lake, you know how water looks like. We know the physical parameters of the water. So in the lake, the big problem is the wind, but otherwise we know everything of the lake water. In the subsurface, the problem is the parameter.
So it's basically a specialized CFD software in a way for those applications.
It is, yeah.
Okay, thank you.
So we just in time for the keynote. So I'm clashed between two keynotes. Who put this? Who is the organizer of the conference?
Let's thanks once again. Yeah. Do you have a sessions here? What? Do you have a sessions here? You sign up for sessions here all the time, as well? That's for This is saying 120, but we changed it to, and this is 119. So yeah, it's a little confusing, but it's right now we are going to collaboration nothing yes. Okay, I'm going to be like I signed for the next session. You need a volunteer part, right? Yeah, but so 192, yes, 188, yeah. Do you have something? Right now, no. Right now it's a keynote in the manual. That's not here. And only after this popular will sign up. Then oh, and the second one will next year. What will oh, because there is nothing to do. No, there is something. 138, I didn't sign because there's two. Okay, I signed here, then here, and here. Okay, so yeah, then you guys after lunch. So I then on so our job is only technical, right? And I also ask the speaker if because we have these two cards, so we can also use them. But this is for Germans. Card, like what? We stand like this? No, I was sitting here, and I just asked him if he wanted to. So I showed him. He nodded, and it just like this. Okay, so we show the person that
The
we
person,
sit-
yeah,
the person. No, the
Okay,
person. So they
right.
know that. Oh, I have only 5 minutes.
So
But
for me, I do this or I
you
pick
can
the
you
marks?
can ask. You can ask. Because sometimes chairman does this.
Okay.
You can ask. Yeah, your responsibility is for mics. You can.
Yeah, like this is open. Okay.
On. Right now, here's where is this? If they connect for this, you need to change the laptop to see their laptop here. And
No, explain me this. I don't understand it.
so if you connect your laptop here,
Yeah.
it's sometimes it's not switch
Okay,
automatically.
so
So
I-
you need to click laptop here.
Great.
And this should work, but it didn't work previously. This is for what is this? Remote control. Something like this. You can switch slides, and
But
there's a laser here.
does me who switch the slides?
No, no. They are doing this. You're only here to help them to set up before. the
Okay, so I
presentation.
tell them, okay, you switch like
Yeah,
this.
but
and-
they need this to be connected to their laptop. This one.
Okay.
This is for the remote control.
Okay, good.
You are not alone. There is always someone
Okay,
else
so
here, but you're responsible for connecting them to the presentation and all technical stuff.
Okay,
It's
great.
show them how to use this stuff, and they will manage.
That's all. Hello, really sorry for late reply. Like, I don't really have time. I wake up so early and I No.
Jest włączony mikrofon.
Raz, dwa, trzy.
Raz, raz, dwa, trzy. Raz, no słabo słychać. Raz, dwa, trzy, raz. Raz, raz, dwa, trzy. No ta pałka chodzi ładnie. Ta jedna słabo. Raz, raz, dwa, trzy. Raz, 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 dwa, trzy. No jedna pałka słabiej tak działa. Po prostu, no. No, no trochę słabiej, no ja wiem dużo. No. Tamta lepiej słychać było, tak? Ale tą też słychać, mi się wydaje. Po prostu. Raz, raz, raz.
And it works like that. Yep.
Olá. Okay, so we can slowly continue. Thank you so much for coming to the session. We will start with Tim. And he will present about reconnecting foundation libraries with their communities. He will talk about successes, failures, opportunities for growth, and surprises in building the NAPARI plugin sustainability initiative. Thank you so much, and the floor is yours.
Thank you very much. Thank you for being here, everybody. This is my first time in Europe that isn't London, so this is really fun for me. So thank you to the organizers. And yeah, today I'll be telling you about a project that I've been working on. That's unfortunate. I received this as a fellowship from the United States Research Software Sustainability Institute for early career. So I want to thank them, and then also the Chan Zuckerberg Initiative, which now I work. When I started on this project, I was working part-time on NAPARI and I was a postdoc, but now I have the opportunity to work full-time at NAPARI. So you'll probably see us around this conference a lot this week. And I can just sort of show you what NAPARI is a little bit briefly. I guess it'll be a little hard to type, but you could try this yourself if you have UV tool run, NAPARI, and then you need all so that you have the GUI part come in. And then in a moment, it'll take a little longer for your first search, but NAPARI is a tool written in Python that, oh no, I didn't write, don't write UVX, that's the wrong command. it's a tool written in Python that allows you to programmatically interact with your data, but then also with n-dimensional data to explore your data with a GUI. And so, for example, we could just open a sample data. You might have heard of Napari and that it's often used with biological data, and that's because the people that started it mostly worked in the life sciences. So here, right, it's n-dimensional. We can scroll through it and see our data. We can also look at it in 3 dimensions. And you can do all sorts of things like annotate your data, so you could paint onto your data, or you could draw regions of interest. And so really it's this interactive way of working with your data and exploring it. And we're trying to branch out into other communities. So if, for example, you're part of any community with data, which is probably most everybody here, this is, for example, the weather. I came here from SciPy. So this was the weather in Minneapolis, which is where I'm from. And on top of this, not just interacting with Napari programmatically, there's this nice integration with a plugin system. And if you don't know what a plugin is it's a Python package that through the configuration file accesses another package through an entry point. But those packages are just installable libraries, but typically a plugin is thought of as an extension, so it often does things that the other tool doesn't. And so Napari, since it was originally made in released to the public in 2019, now has over 640 community plugins, which I think is a lot. Those plugins can extend things like what file formats can be read. It can extend the UI, so new ways to maybe interact with and annotate your data. Now there's many AI integrations, whether that's deep learning models or people hooking up LLMs to segment your data in natural language. And then there's also many domain-specific analyses. As I mentioned, a lot of the work has been done in the life sciences, but people are starting to branch out into other domains like geosciences, astronomy. We can see we all have lots of data and big data. So when I'm saying in the title a foundational library, right, a lot of times I think we think towards the center of this shell where we're thinking about NumPy or SciPy, things that are depended on in many layers. But I think another way to think of a foundational library, something like AstroPy or Napari, is that many people depend on the functionality of that library and often extend it, right, with plugins, but such that this upstream library, the foundational one, has to be really mindful about how everyone interacts with their work. And so Napari was released to the public in 2019. On the left, we can see active contributors, so those are kind of committing within a 6-month period. And there's this rapid growth towards 2021. As I mentioned, the Chan Zuckerberg Initiative wasn't involved originally in Napari's growth. There were people that were employed at the CZI, but they also, with those gray arrows, in 2021 and 2022, released 2 plugin accelerator grants. So the plugin sort of construction machinery had just been built, and CZI really wanted this to be adopted in the community. So not only did people start to contribute to Napari, but as we can see on the right, matching the period of times that these plugin grants were released, many people started to make plugins. Since that time, the number of plugins has steadily decreased, but we're starting to see that. And I've cut off here a window at the end of 2025 because that is right before the Plugin Sustainability Initiative starts. So we see that there was momentum. This was community momentum for myself. This is actually what attracted me to Napari in 2022. And we've seen that go downhill. And what that looks like when we go downhill is we can see the pink background shade is the number of plugins being like that exist over time, and it just kind of rockets up. In the blue, we can see the number of plugins that are actively maintained. So whether or not they've had some kind of release in the last 6 months. Not everything needs a re-release, but there's a few important parts about Napari here. Napari was quite immature at the time that the plugin infrastructure was made. And so these plugins were built on top of often rapidly evolving APIs. They sometimes had to use private internals in order to accomplish what they want. And so if those aren't maintained, they will break over time. These plugins are often developed by domain science who either don't have the expertise or the time or move on in their career to continue to maintain plugins. And then dependency libraries actually became a big issue for us as we transitioned from having sort of Python 3.7 to 3.910 support to now these more modern Pythons and the many packages that have evolved. And what that looks like, and sort of if we want to inspect like plugins and say, okay, not just are they being less maintained, but what does that actually practically mean? If we look at their configuration files, like something like pyproject.toml, these are the Trove classifiers saying what version of that package it supports. It's not that it can't be on a newer one, but this is probably the last time this package was touched. We can really see that peak of 3.10 in the middle, which is roughly when those plugin accelerator grants were happening. So since the plugin accelerator grants haven't been made anymore, we're seeing a steady decline in sort of adoption of these newer Python versions, and particularly 3.14 is right now only at 30 plugins. And that's if we can look at it from the code perspective. From the human perspective, even 1 year after those plugin accelerator grants, when there were workshops and tutorials and online instructional materials being released, respondents to our survey said that making a plugin was easy. But then in the text entry box, the most common theme was that maintaining a plugin was hard or confusing or overall a burden. And so there's a few things that are sort of worth iterating here, and kind of the point at which I kind of was looking at this as I came into Napari as someone that used plugins only and didn't write Python code, is that they're often critical to the workflows of users. And because of this, you don't want to update your Napari version or your plugin version for fear that your workflow may break, or if you've done that experience, it's a very bad experience. And over time, this creates distrust and a disconnect between the communities, where at one point, both sort of the core Napari project and plugins were kind of the same users kind of working together over time. But as those sort of separated, there was loss of trust and loss of interaction between those communities. And the reason I sort of know this is because I started my postdoc in 2022, and that's where I learned about Napari. I was using something written in Java that started in the 90s called ImageJ or Fiji. It's often used in the life sciences. And it has limitations now with some of the bigger data that we get. So in 2023, I began to write my own plugin. Actually, this was inspired by the work of Draga in the back of the room. And she made a video that I watched many times. And it wasn't until 2024 that I made my first PR to the core Napari project. And this was actually after I went to a conference like this one, and people were really encouraging me, hey, you should maybe contribute upstream. After that, I became a member of the core team, and then they added me to be the community manager for the project. I sort of joke here that I don't like the word manager. Maybe gardener is a good word for that. You'll actually see in my talk today how I think about things from a community management perspective. And then in last year, I went to SciPy in July. That was the best conference I'd ever been to, and it was very inspiring. And it kickstarted a lot of interaction with a lot of people. So I hope I can help you make some connections here. But this plugin sustainability was received from the EuroSciPy Fellowship, and this began. And so I framed the plugin sustainability initiative grant around the problem that we have, is that as these communities drifted apart, the relationship, instead of one that was working together and collaborative, became transactional. I need X to work. Will you do this for me? And people would often say, no, we can't have it work that way, or yes, we can. But it became a lot more transactional in nature. So my hypothesis was that if we build a more sustainable ecosystem overall, then everyone would benefit. Both the upstream library would benefit, and the community downstream would benefit. So I framed the initiative around two key ideas: that we needed to build, or rather rebuild, the community. And we were going to do this with shared approaches to review and sustainability. And this was really modeled after other scientific Python communities. So where I was at SciPy, and I met folks from PyOpenSci, or the Scientific Python, and those different groups that are really thinking, how can we make good, sustainable scientific Python code? And in addition to that, we would build tools and features. So there are originally agreed upon goals of like how the plugin ecosystem would work that weren't implemented. But then also tools like we have a template in order to make things that they would be remaintained. And so that's where I began community building in October of last year. I made a call to action. So I released on social media and then our sort of regular chats like Zulip. I'm someone that doesn't personally use social media, but you'll see throughout my talk here that social media is a really important way to reach your community. And that's hard for me because that's my job, to make the social media posts a lot of times. But one of the things that we got, we made a survey, and a lot of people gave more feedback than I expected, both either kind of chatting back and forth or filling out the survey. People were very interested in this work happening, but most people wanted to be an observer, which sort of tells me two things. This is something that's really important to people, but it's also something that people often don't have time for. And so we really need to kind of balance both of those pieces as we go forward. But enough people did decide that they wanted to kind of participate that we started to have weekly plugin community meetings, where for an hour we would meet with different people, and it was great. We got a lot of sort of time to really hash out some of the more complex details, which is where a lot of this has blossomed from. And we continue our discussion on our Zulip. And finally, I made a blog post, which you could read on nepari.org/islanddispatch. But the key points of this blog post are that we would have an automated and community review system, that there would be modernization of plugin tooling, and that there would be better discoverability and ecosystem communication. So no longer would no one know how to find your plugin or what plugins maybe the community thought were good. Because oftentimes it happens, I have a ZAR file. I want to read a ZAR file. What is the best ZAR reader? Well, technically there's no right answer to that. But partly what they're asking is, help me get started. Help me filter through all of this complicated stuff because I'm new or I have a certain goal that I want to achieve. So we started with automated and community review, and one thing is that this is sort of the goal, and I had some things that kind of steered this away from this, but we would like to get here, and so that's all I can present. The interest is that we would have automated review tooling. You'll see that in this talk with some of the charts that I've made. But also people were surprisingly really motivated about a human peer review system. So this is something that reminds me of PyOpenSci, which you can like submit your package to, they'll look through it, make sure it's up to standards, and have a conversation with you. They also want a tiered recognition system. And one of the important parts here that we had a discussion is that you don't want to give a plugin like 5 stars or a plus and minus, because over time that creates sort of things that just have momentum going to the top and not necessarily things that could be discovered that might be released, say, in the year of 2026, but hasn't been around for 4 years. And the idea that we settled on is that we would have maybe Nepari Essentials, which is something like a plugin that Nepari might maintain, like Nepari Metadata, or community ones. But then we would have 2 categories, sort of community reviewed, which means you went through the review process, and this is the community way of saying, hey, this is at least something that we think could be useful for you and is being sustained. But then also our automated tooling might say something like dependencies verified, like this actually works with modern Nepari, which currently doesn't happen. You can install a plugin directly from our UI and completely break your environment because it can just install any version. And with that, people wanted to also have a shared community maintenance programs. So we always talk about code that goes to die. This often happens in scientific communities. Someone moves on from their academic position and it stays there. People want a way to actually internalize that, say, I want to either donate my plugin so that it can be maintained and someone could volunteer, but then also the other way where you can kind of build up that community together. And this all surprised me because I think sometimes we end up in little silos over time and don't realize how much people want to actually work together, and we want to enable that. So a few things happened, and that's why that had to stop. I had a family emergency sort of starting at the beginning of this year, and then also I'm from Minneapolis, which you might have heard about in global news with ICE, that really affected my day-to-day. So I kind of had to steer away from this community-facing stuff for a bit, and at the same time I started full-time on Nepari. So instead, I focused on the quiet things that I thought honestly would not make a difference and really just go in the background and that would be it. And I wasn't working very hard. And I was kind of quite ashamed of this. This was a difficult part when I was preparing my talk because I actually felt like I didn't accomplish my goals to sort of create these tools and these communities. But I've learned that through things like overhauling the tooling, our tooling is something like a Nepari plugin template. It's a copier template. You might have heard of Cookie Cutter. They're similar. You can run this, answer a bunch of questions, and you can have a fully generated Nepari package ready to go and be published to PyPy in about 30 seconds of work. I did an entire refresh of the documentation. NPE2 is our plugin architecture. I started to learn about that and slowly am now starting to build up contributions to actually finish those goals. And then also we're working on the Napari Hub, which is that page I showed you at the beginning. That's where we can find searches. And one of the things I'll even say about the Napari Hub is that even just talking about the problems that I've had with Napari Hub and the work that I've had to do has already recruited 2 new people who seem quite dedicated with the number of PRs that they have to be actually working on this and fixing this. So really be open to what you need to work on. That's all people need to know sometimes. A lot of people are really eager to help. But through this work, I learned that this still conveyed that the core project cared. And so even if you make a pull request and it gets merged in some repo that has 2 stars that no one pays attention to, because why would they? It's just infrastructure. People are watching that for some reason. People either see what you're doing or that you have conversations in your community chats. And that really does make a difference. The important part here is that you have to talk about it, though, when these are the quiet things, saying, this is what we've worked on in plugins, or does this work, and reaching out to people. And that last part in parenthesis is something that I don't like to do. I just like to do my work and kind of move on. But something that came up at SciPy this year is that you really have to market your own work. If you think your work can make a difference in the world and that's your goal, then you need to talk about it, because otherwise people won't know. Another surprise from all of this is that while I was trying to build what I thought was a shared community, because at the time that this all started, I wasn't sort of as full-time on Napari and kind of core to it, I really wanted to build a group. Things like doing the quiet work or doing this organizational work built that shared community, but people kept telling me they appreciated the leadership that I was providing, something to look towards. We often have these 2 pictures of leadership. You definitely don't want to be the boss, where you're telling everyone how to work, right? And then they say there's this sort of leader that's kind of in the front and maybe pulling everyone behind. And I think that's still an important leadership role. But when we're in a open source community where what you're trying to have is shared ownership, I don't think that quite works. I don't think that's what leadership is here. It's definitely not high trust behavior, or whatever this image of leadership is, where you shoot an arrow at people. Don't do that. That's what happens when you Google leadership images. It's that leadership needs to have trust in order to be established. So doing that quiet work to say, yes, I'm actually going to do this and not just say that I am, it also builds trust. And so this still isn't a great representative image, but I think we can think of this differently. We had this idea, the problem of a transactional or service relationship between Napari and its community. And instead of that, we're still serving, but you can think of it as a servant form of leadership, where you do work in order to bring up and build others, maybe, grow their work. But it's thinking about your leadership as a way of being a servant towards other people. And that, surprisingly, I think is what built more shared ownership as more people started to contribute in these libraries than had ever done so before. But then AI changed how folks interacted with plugin development and community. We all know how AI has particularly changed so much since the fall of last year. It's become so accessible. It's become easy for someone to use natural language to make code. And so now we see this change here. We see a rapid change. This is the gray box is where the plugin sustainability initiative started. And my hypothesis was that, this is just because LLMs exist, people want to play around and have plugins. And I shared this to quite a few people. And all I can tell you right now is when I tell that to people, they say, no, Tim, it's the work that you're doing, which feels very awkward for me to say. I don't like to talk that way. But one of the reasons that I want to share that with you is because I think that's part of what we can do is take these things and hope that it isn't just LLMs, but things have started to change. That doesn't necessarily mean that that's good work being done. So we'll talk about maybe what that looks like. Here's how I think AI changed things. I have a new hypothesis, and that's that AI has changed how the question mark works. So for many of us, if we started a few years ago before AI was popular, questions were something that you had to do with another human being. even if that question was going to Stack Overflow and reading someone's answers from 8 years ago. I think that shows the value of asking questions because they're still useful. But you had to do that. And often you had to do that very early on. You got stuck quite early. You had to ask a question that you maybe would feel ashamed about, and maybe someone wouldn't respond so great. But hopefully Napari community is wonderful when we answer questions. I think LLMs have made the question mark disappear. Because instead of going to the human, you now go to the LLM to ask a question. And I say this with full sense that I am so tempted to do this myself. So when I have a simple question that I feel like I should know as someone that maintains Napari, I want to ask the LLM. And over the past month, I've been trying to be extra conscious about asking the community some of these questions, which maybe feel like, should it work this way or not? I think what happens, though, we need to model this, because otherwise the question mark gets really big. Instead of a normal question mark, someone's worked on things for 3 months or weeks or many hours, and the LLM will keep iterating to try and make a solution. And they're so deep, and if you are a maintainer, you've seen this before, where you get a 20-paragraph essay on a bug request, on like a bug or some feature that they want, and suddenly your workload becomes much heavier. And you want to think about, we want to avoid this. So I think that as maintainers or people interested in projects, we want to come back to the regular sized question mark. And this is part of building our community back, and I think being models for other people on how we interact. I think the other part that I've learned is related to leadership and this whole project in general, which is that curiosity is actually what drives a shared ecosystem. So if I were just to do this work, especially because a lot of people thought about things 4 years ago and how things should work, and I just went with that, it wouldn't meet the needs of our community today. And so curiosity is a way that people would see that I continued to care, and it allows you to respond and understand the needs of others. But one of the keys here is that I actively sought out people. So what that looks like, for example, is I will find them on social media or on our chats, or I will follow their GitHub. I will follow their plugin repositories. Because then what you start to see is the people downstream of your library are making like workaround bug fixes in their own code that should probably be contributed upstream. And you don't want that. You want to say, so I go in there and I just say, hey, this looks like it would be a really good thing to put in Napari. Why don't we talk about that? And then we get two things. We get it in Napari so everyone can benefit, and we also get new contributors. And I think so far the success rate on this has been people that I seek out this way don't just make that first change. They have started to talk more issues, more chats in our Zulip, and most of them have made multiple pull requests, I think all but one. So my advice to you is follow people and reach out. And that is something that seems time consuming, but it is very worth it. I think the growth that you get from that is to do that. And so just ask. And I was thinking about the growth of our team this past year, and actually the 4 people that have made a really big difference. So we've got in blue our new core team members. Jaime Rodriguez Guerrera is a member of QuantSite and has been working on Python for years. He knows what he's doing, way more than I do. But one of the things I love about Jaime even is that he asks questions when he makes pull requests or issues. He's trying to always open that conversation. And then our other members, we've got 2 new members from the triage team and Carlos on the core team here. And they are all people I realized thinking about why are they different than some other contributors? They ask a lot of questions themselves. So I think we can really model that. And I think we're starting to see a change. This is like a core contribution to Napari here. This was very recent. And not normally do when you make I was off for 3 days. So I took off Friday to go camping. I saw this pop up and I was like, oh, I'll get to it Monday. Come Monday, 4 people had approved of it. 5 had commented. This many people had participated. And why I say this is because this was a relatively small PR, but it was about plugins. It was something that people had wanted for a while. And this is very true. The recent plugin changes have gotten so much feedback, and I'm kind of surprised from the core team because I'm like, we really struggled to get momentum, but when we see other people do this work, it helps. So build that community. And what that looks like is folks indeed are not only beginning to contribute, but this is folks that contribute and then contribute again. We're seeing new sort of non-plugin developers, but also in the orange, we're seeing plugin developers continue to contribute. And this is maybe one of my favorite plots so far. And we could see the growth in active contributors per year over time. We had that peak in 2022, and it steadily decreased. But now we're just a little over halfway through 2026, and we're already on pace to potentially smash those previous years. We're seeing more maintenance. So before we had that blue plot, they're being actively maintained. We're finally seeing that. That proportion is going up, and I hope to see this continue to go up more. So hopefully the efforts of all of this are mattering. We're going to track things on individual plugins, expose all of those things that I previously told you about, and create that shared ecosystem. If anyone would like to work on that with me, that would be great. I asked this question because I did so at SciPy, and now I'm going to be working on the Scientific Python repo review tool, which if you've never used it is really great. And my advice is to invest in people, not Python. So all of these are important because they involve people. Treat people as partners, share ownership, collaborate, do peer review. People are interested in that. And then recognize all the sorts of contributions, not just PRs. So with that, I invite you to join us. We actually have the opportunity to be a sponsor this year. There's our pierogi logo for Poland. After EuroSciPy, though, we also invite you to join our hackathon. We'll be doing a 5-day hackathon here at the university. We can do workshops. There'll be a tutorial later this week. Join us on our Zulip chat. And the representatives here at this conference today are myself, Draga, Lorenzo, and Gregosh. So thank you, everybody. And with that, you all get a bird video if it loads. Every new contributor gets a bird video. So this whole talk was an excuse for me to give you birds. So if you contribute, I'll give you birds. And if anyone wants to go birding while we're at EuroSciPy, that'd be great. We do the same thing at SciPy. So thank you.
So thank you so much, Tim, for your very insightful talk. So we are a little bit behind schedule, but it is so important to make questions, as Tim mentioned. So we will make space for questions. Who has questions?
Hi, my name is Sudipto. I also maintain a small Python project named Sudivis. My question for you is like, what are the challenges you face as a maintainer, and how do you resolve them at times?
So the question was about challenges. I think the biggest one that we're all facing, and this was the theme at SciPy as well, is that how LLMs have really changed what the expectations and the needs and time demands of contributors are. And so I tried to touch on that here. I really do think we want to think about how we interact with those. I think questions are really one way to do that. So if you're not sure if someone's really genuine, just asking them a few questions can save you a lot of time rather than investigating the whole thing. You get feedback pretty quickly from them if they want to learn and things like that. I think that's the other challenge, is sort of knowing what someone wants in the future. And that's, again, where just asking them can help. And that took me a while to learn. I used to try to figure everything out before answering. And now I've learned to why not just ask people, invite them. That's what we can do to help the most, I think.
So somebody has more questions. We would have time to just one more question. If so, if not, you can talk with Tim later on. And thank you so much once again.
Thank you, everybody.
All right, we have a short interval, and let's meet here in 10 minutes.
command view within, because you need to change the source, right? And can I like click, or is it you want to change the? Sorry, our technician is calling me. Co jest, Dawid? No. Ale w sensie... No. Okay. Wow. Okay, dobra, dzięki. I think wow, he's watching us live and he called me to tell me what.
Exactly. Perfect.
Okay. So.
All right. Thank you so much for joining this session. We're going to start with Daniele, and he will talk about building a scientific taxonomy at a scale with graph clustering, embeddings, and LLMs. Thank you so much. The stage is yours.
Okay, thank you. And hi, everyone, and thank you very much for being here. It's a great pleasure for me to be on this stage. Today, I'm going to talk about a project I've been working with my team over the last few months. So let's get started. A brief introduction first. My name is Daniele Raimondi, and I have a background in statistics. I work as a senior data scientist for MDPI. My passions are mostly statistics, data science, finance, research, and many others, but I don't want you to get bored about this. So, as mentioned, I am working for MDPI, which is one of the world's largest open access publisher in the world. So far, in the 30 years of experience, as soon as it's been settled, this company, we've been published around 2 million papers, spanning through more than 500 journals. So you can well imagine how many major scientific disciplines we're covering. And as you can imagine, a paper is composed by a title, abstract, full text, and also author keywords, where this is, I want to focus on this because it's the starting point where my talk and my project is starting from. So the real goal was paper classification. I'm giving another talk tomorrow, which is about paper tagging, but is the last part. Today, I'm more focusing on how we built the 5-level taxonomy. So something something composed with domain, field, subfield, topics, and concept. And after we have this representation, we were able to tag our 2 million papers to this concept list, depending on their semantic. So, as mentioned, just a brief introduction. Later, we are going more in detail. Existing taxonomies were too coarse for our task. So our goal for this building taxonomy was to trying to reduce the noise from author keywords to something more standardized and structured. And all the providers we found out online were not precise enough to be used for our specific task. So what we did was to take the 4-level taxonomy from OpenAlex, which is a CC0 license, so we can take advantage of this, which OpenAlex is an open catalog spanning all the knowledge about scientific research. So we took advantage of this. So 4 domains, 26 fields, 252 subfields, 4K 516 topics, but this was not still granular enough for our task. So what we did was to build a 5th level, and we will see all the pipeline we built to achieve this. So for example, a domain is something like physical science, a field is computer science, a subfield can be artificial intelligence, a topic can be machine learning and algorithms, while a concept, which is our level that we wanted to achieve, is something more specific, like boosting algorithms, okay? So 5th level is our contribution. So, as mentioned before, raw authors keywords are can be spelled many different ways. It's just a string, a text strings, and it can be, for example, for Industry 5.0, can be written in many multiple ways, in different languages, in different ways. And we cannot state which discipline this is belonging to, because again, it's just a string. So, for example, Industry 5.0 can belong to digital twins, smart manufacturing, work automation, and whatever else. So what we wanted to have here, it was something to a canonical concept like Industry 5.0 written in a precise way and connected to a specific hierarchy tree. For example, first one can be attached to something related with data and IoT technologies. The second one can be related with something about manufacturing, and the third one about innovation, sustainability, and so on. So many challenges before we had to start about this project. So the scale, we have millions of papers, we have millions of keywords, and so manual curation doesn't scale. LLM only, we cannot afford only using LLMs because, of course, there is a problem of scale and in cost. And for example, we could not use simple NLP or regex or something like this because since we cannot catch the semantic behind it. So every LLM call has a cost, and so we had to find also ways to manage this. Of course, maintenance again, because science doesn't stand still. Science evolves, so we cannot take a snapshot today and then forget about this and continue tag our papers in the future, because many models, many architectures, and many proteins or whatever can be found or whatever. So we have also to think about this, how to update it. And of course, there is another issue about ambiguity, because even domain experts can disagree on something in science. So we had to, of course, LLMs are probabilistic and we cannot fix 100% this problem, but it was something we had to rely on. So now we can go a bit more in detail how we built it. So the pipeline and the workflow, and this is just a schematic view that we built just to let you introduced about this. If you look at the bottom, for example, we started with a huge amount of keywords, and we had to find a way to reduce this complexity, to make it standardized using LLMs, embeddings, and graph clustering to group all these concepts, these keywords together. Then after we found out, we built a 5th level. It was just a pool of standardized and structured concept, but what we wanted to have was to attach to the topic level, so the 4th level from OpenAlex. So in the end, this is just a way from starting from raw author keywords to concepts, what we call concepts in the end, okay? So everything or most of the tasks we were using in order to reduce the LLM cost and LLM calls was trying to use smart ways to use, for example, something more deterministic, or using intensively Python to reduce the input asked for an LLM, And we were using intensively Spectre2, which is a scientific document embedding you can find in Hugging Face, which converts paper title and abstract into a 768-dimensional representation. So you can well understand that in this way, we are able to translate text into numbers that can be processed by any of our models. And the architecture around it is built on Cybert, and is pre-trained with contrastive triplet loss on around 6 million papers. So the goal is trying to get closer the papers that are cited each other, and more far away in the space the ones that are not. So this was in a nutshell how it was the contribution of Spectre2 and why we are using this embedding model for this. And it can be used, as mentioned, in many different ways, since you translate text into numbers from document retrieval, clustering, recommendation, or any other kind of applications. And we can start now, starting from a very easy, very initial pre-processing steps, where our goal was to reduce the big noise around these author keywords. As mentioned, a keyword can be written, for example, machine learning algorithms. So all of these very similar ways to write a keyword. We were trying to use regex, NLP, or anything using embeddings. Trying to use a very high cousin similarity in order to find a way to reduce the initial number of this keyword. So this is just a very easy step, but just to reduce redundancies. So anything like open access journal, open access material, open access publication, all of these were merged, where we kept only one of these instead of all of these three, because of course they were mentioning kind of the same concept. So after we reduced this keyword list, we were using our first LLM stage. So our goal was to remember something that was okay for a fifth level, So we were using, we built this pipeline, GPT-5 was just released. And we were starting using GPT-4o Mini at the beginning, because since it provides a log prob of the classes that is trying to predict. So this is a sort of two-stage, multi-class, three-class few-shot classification. We get a confidence score. So we are asking with a prompt, what about this concept? Is this too broad? So something that already is in first level till the fourth level of a hierarchy. Is it just right? Just, for example, federated learning or diffusion models, or is something too narrow? For example, bird-based uncased, or any protein name, which we would like to discard, okay? So thanks with these log probes, we were able to exponential these log probes to have a sort of probability of confidence score. And if this was very higher than a threshold, so the model was quite sure that was belonging to one of these three classes, we were outputting and selecting this class. Otherwise, we were asking a more intelligent, clever model. GPT-5 Mini was just released, and to have another pass to define it. So in this way, we were discarding everything which was too broad, like artificial intelligence or physics that is not belonging to this level, from anything too narrow. So we were filtering, but here we needed something more clever, like an LLM. And after this, how we can go more, how we can reduce and go more in detail. So what we did was, of course, asking many questions, and we decided to classify each concept to a field first, because since we have 26 fields and 4K516 topics, of course, the easiest way for us was to, classify on a topic level, but you can well imagine the input tokens will be too much, and also the accuracy, the precision of the outputs would be very low, because we are asking an LLM to classify too many things. So what we were trying to understand to do was, for example, Industry 5.0 can belong in computer science, engineering, and social science, for example, 3 out of 26 OpenAlex fields. So we first decided to go through a per field clustering, because why? And not to have a clustering based on all the fields there, because our idea was that, for example, network can be something, it can connect something like computer science, biology, economics, For example, also models spans through statistics and physics and many other things. So we decided to build 26 clustering approach, so separate per field, in order to have something more precise and predefined. So each field contains semantically homogeneous keywords. And this was something that improved a lot our final results. So here, again, after we decided this, we were asking LLM to have a sort of field classification this moment. So it's based on 2 steps, because we realized that if we wanted to use a single step, the results were not sufficiently good enough. So the first one is a multi-label zero-shot classification, where we did a huge prompt engineering there, and we were providing concept name and explanation that was created by, again, an LLM for each of these concept keywords that we had. So thanks with this, we were providing also the 26 fields with the description that we generated. And actually, in the first pass, we had also some false positive. We knew it, but the idea was to have, okay, you have a concept, and you can provide us your confidence score for each of these fields. So the more the model was sure, the higher this confidence score. But of course, here again, we could have also some false positive. And we had a multi-pass validation, so it's a zero-shot binary validation. So for each of these fields that were very high, with higher threshold, so we didn't use all the 26, of course, but only the ones with very high threshold. And we decided to ask, okay, you have this concept, you are providing with this specific single field. So we were asking yes or no. So this is a binary, and in this way, LLM was easier for the LLM to discriminate between yes or no. Do we have to keep this or not? Is this fields really related with this concept or not? So in this way, we were shrinking very, very much the amount of fields of our field distribution, field hierarchy tree. And in this way, we reduced and started to attach our concept to specific areas in our trees distribution, in our pyramid, okay? So after we have this, again, we had a lot of not duplication, yes, but something very, very related to each other, okay? So we wanted to shrink more and more, because again, here we were around 1 million keyword left. So we were reducing many millions keywords with these steps. But again, we had to find a way to really reduce redundancies and have something more reliable. So we were thinking which kind of clustering method could we use, and we decided to use Leiden clustering, since compared to all the other ones, we could use the communality and the fact that we can build some graphs based on their cosine similarities or their strength of their connections, which all the other methods this was not able to have. So we first treated each keywords as a node. The edge was the cosine similarity between them, and we wanted to use a mutual KNN. So first we were indexing with KNN, and we were considering only the ones that had both mutual KNN. In this way, we had something more sparse representation, and we could use could speed up the Leiden model in their convergence. In this way, we had to define out of our hyperparameters K how many nearest neighbors, the similarity minimum to be kept for this similarity, cosine similarity between these nodes, and the Leiden resolution, so how much we wanted to zoom in or zoom out. And we built two must link and should not link lists, which were created by us. So a sort of a list of concept that we wanted based on the results we were seeing to be connected, and the ones that we didn't want to be connected each other. We found out this kind of hyperparameter set, and it was around 75,000 distinct concepts in the end. Then we built many visualization with network X and bokeh, in order to visualize and inspect, go back and forth to improve our models. And this is just an example where we were using LLM for the third time, where we were renaming each cluster and building an explanation. So we had sheet metal fabrication, metal fabrication, and sheet metal, and we renamed as a sheet metal working with a LLM explanation. So this was the real final concept name based on all the keywords coming from our list. So in the end, we built up now a fifth level, so a sort of pool of a lot of different concepts, and the goal was to attach it to the fourth level. So as mentioned, we built topic name and explanations. This is a retriever by encoder, so we were embedding with Spectre2 the concept name and explanation, and also the topic. Okay, so based on this, we wanted to reduce candidates because again we had 4K topics, so we wanted to select only the ones that were more semantically close in the space. And we were provided with top 10 candidates by cousin similarity. And again, we were using at this stage, when we reduced and shrink the distribution, the count, another LLM in order to attach it. Okay, so we were asking with a prompt, given a concept and explanation in the top 10 topics, please let me know which of these candidates are related semantically in the hierarchy. Okay, so there is all the context between from domain till topics. So it's a sort of LLM re-ranker. So we wanted to select only the most connected ones. And lately, we were also doing some post-processing checks for reliability. So we didn't want a concept to be attached to two topics belonging to the same subfields, or we were just controlling if OpenAlex, if there was something related, a collision with OpenAlex for first 4 layers in our list, or we were checking for similarity threshold. If some of these concepts were too close each other, we were threading again in order to clean them up. And lastly, as mentioned, we were keeping an eye on keeping the taxonomy alive. Okay, so what we did was first to build a percentile small model, where in the last 9 months and in the last 5 years, we were building 2 columns, 2 vectors about which position this keyword were in the percentile counting distribution for our papers. And actually what we wanted to achieve, what we wanted to get was, okay, let's get the most frequent concept in the last 9 months that were very low in the distribution percentile rank in the last 5 years. So it means that the distribution count in the last few months is raising a lot for these keywords. And then again, after we had these initial keywords, we were using the same pipeline for it till the end. So everything and in this way, we were able to attach and append to the fifth level and augmenting time over time this list. And I would like just to let you see a very quick streamlit that we built on top of this, just to explore it. So, for example, here you have the four domains. You can select, for example, physical science. You can go through, I don't know, mathematics, which is a field. You can see all the subfield here. For example, we select statistics and probability. Here you can see all the topics belonging to this. For example, okay, let's go for statistical method and inference. And again, here you can see all the concepts that we built, and you can even go through it and inspect it. So this is just a quick distribution, just to let you know how we keep also track of this. And some lesson we learned, just to close my talk. The first one is, don't plan too far ahead, because this was a project where we really back and forth, because we planned something, then we found out that from our study that maybe it was better to do something different at the beginning, so we went back, and maybe other models, LLM models, were just released, so we wanted to see if this new better model was achieving better results. So the first thing we learned is, don't plan too far ahead for something like this sequential in this LLM and embeddings word. Another one is, don't let the LLM do what Python can, because of course, since we have to scale with millions and millions, we had this problem, so we had to use embeddings, many ways to reduce it and to reduce our costs. The third one is to use the right tool, not the biggest one. Of course, we could have used some better flagship models like GPT-5 or whatever, but the cost is another problem, as I mentioned before. And constant human in the loop, just to keep track of this day by day and results by results. Don't let cursor or any Claude code go behind the scenes, but every time have a look on it. So that's all, and I want to thank you.
So thank you so much, Daniela, for your talk. Really insightful. We're a little bit behind schedule, but let's do some questions, 1 or 2 questions. Yes.
Hi, it was a great talk. I just wanted to ask that you mentioned that it was a zero-shot learning that you did with the first pass in the LLMs, where there was firstly they were introduced. So did you try to give some context in the prompt that they have some context about how they should classify and try with the few-shot learning?
Yeah, sure. So we provide a lot of context. We also provide many examples. So for example, try to do this. So examples, you have this concept and please connect to this field or whatever. We tried a lot of this to provide some shots. But in the end, we realized that providing these shots, these examples, we didn't improve that much, and we were a bit scared that maybe we were leaking some potential results or leaking some distributions. So, for example, if the examples were in computer science or whatever, we were scared that maybe the final distribution was a bit biased because of this. So we provided, in the end, a lot of context without providing any example. So that's why we recall it like a zero shot, but actually there was a lot of context around it.
Okay, and you mentioned that there was lead-in clustering. So I just wanted to ask that changing the resolution, did it change the clustering itself, and how much was the effect?
Yes, sure. So that's since we had 3 parameters in the end, we wanted to keep not that much complex in order not to overfit or something or lose control. So just light and resolution here is a 3rd parameter here. And actually this was very important because it was the final counting was very depending on this parameter, okay? So since we had something in our mind that we wanted 50,000 or 100,000 distinct concepts in the end, we were controlling this parameter because we didn't want to have something too much broad, so maybe 300, 500K, or just something too narrow like 20K, okay? So we were also trying to decide this parameter based on these precisions that are coming from these 2 lists that we built up. And of course, we were taking care of this, especially thinking about the final count and not only these precision scores we got from this testing in-house.
So thank you so much. We unfortunately don't have time for more questions, but you can always reach out Daniela after, and we will be excited to hear the part 2 tomorrow. Thank you so much, and let's have some lunch.